So again, super happy to have you all here. And yeah, let's just dive into our first segment here. So we have cloud advocate Cassie, and she's going to be talking with Sarah Ewing about her session on predictive maintenance use cases.
Thank you so much for that amazing intro. I am super excited to be here. I'm extremely passionate about diversity in tech. That statistic of 92% identifying as male is one of those things that shows the importance of events like this and why we're here today. So as you said, I'm Cassie Brevu. I'm a cloud developer advocate at Microsoft focusing on AI. And I am here with Sarah, and I'm super excited to talk about her session because I got to watch it and it was awesome. So why don't you tell me a little bit about you, Sarah?
Well, my name's Sarah, and I am a data scientist. I really love data, and I'm really passionate about it. I also run a meetup group, and I have a podcast called Sarah in Tech.
That's awesome. So in your talk, you talked a little bit about predictive maintenance, which we're going to learn a little bit more about. But first, let's talk about how you got started in data science. There's a lot of different ways to get started in data science and tech in general. And there may be people watching now that are kind of interested in starting this journey. So I would love to hear more about yours.
Well, my story is probably similar to a lot of people in that I didn't start out in tech. I've never taken a programming class. It's kind of been a winding road where I started out in biology with endangered turtles. And I realized while doing experiments, not hurting the endangered turtles at all, that every time you did an experiment, you had to do statistics and you had to do a p-value and everything. And I already loved math. So going down that path even further, started taking stats classes in undergrad and realized that I love statistics. Unfortunately, or fortunately, you have to learn to program. So I did eventually learn to do that on the way. I ended up getting a master's in stats and realizing that big data statistics, while not entirely data science, definitely steps into that realm. And I found it fascinating, like, what do you do when you have so much data? And I just really love the data science space.
That's awesome. I love talking to other people with non-traditional paths because I think they're really inspiring because there's kind of a stereotype of you had to get a computer science degree. You had to be like programming since you were 5 years old. Like there's like all these kind of stereotypes around it, which are really not true. And so I have a non-traditional path as well. And I started, like I wrote my first code in Excel with VBA macros. And so like if you have an interest in something, you just have to try and start. And I think one of the biggest ways that we can actually counteract some of these stats that we're seeing is by career switchers like you and me. And I think they bring a really interesting perspective into the field as well. People that switch careers and kind of are coming in because you bring all that prior knowledge, like all that biology knowledge is super probably useful and impactful in your day-to-day work as a data scientist. So tell me a little bit more about the role of a data scientist.
So it's not just the cool part where you stick ML onto data. You, unfortunately or fortunately, have to spend 90% of your time cleaning the data, getting the data into a place where you can actually do data science to it. And so there's a lot of other hands that touch it before it gets to me. It has to go into a database and all of that and be put kind of into a structured table, if you will. And then even after that, some of the data it isn't clean. So you have to go in and clean it, explore it, mine it, see if there's any trends going on it. And then after all of that, you can do the fun machine learning and AI and all of that. And then afterwards, you do the production and the GUI interfaces and all of that. I've been involved on all of these different levels. So it's a very diverse field. It's not just going in, combating all of it and throwing the model in. It's very wide.
That's true. And a lot of the tutorials focus on building the model when so much more of it is getting data, processing data, cleaning data, and making it ready for training. So that's a really good point and something that I think many people don't realize. And also, it's interesting that you've done the full kind of like all the different roles that go into building a model, because a lot of people kind of specialize in one kind of area of data science. So or of the model building process, I should say, from, collecting data to cleaning it, to processing it, to building models, to doing like ML ops and production. So you've kind of done all of those different roles. Can you tell me a little bit more about each and the ones that you've done?
So I don't put the data in the database. I'm not good at data engineering yet. but one day I hope to be. So that's the person that puts the data into the database, makes sure that the database is balanced and doesn't fall over, if you will. But after that, creating all the sign-ins and logons into, I think I've worked with over 10 to 15 different database styles, and pulling the data out and cleaning it and exploring it, that's actually very time consuming. It's like, can the height of a human be -1? Probably not. And so you just have to use common sense. But looking at millions, billions, I've worked with well over 6 billion records for one data set. It's very difficult to deal with. But you have to kind of use common sense. Like, can you make a purchase that's negative? Yeah, you actually can. It's when it gets refunded. But sometimes you have to work with subject matter experts to come to these conclusions that that's the transaction that was there. So there's a lot of different things going on in that space, and it's very time consuming to clean, explore data. And I would say that that is most of my job. And I honestly love it. I love going in, cleaning, and exploring. The actual model building sometimes makes me nervous because you don't always know if you can make a model predict what's going to happen in the future. But I know 100% that I can clean data and I can go in and mine it and explore it and graph it. And so it's just time consuming.
Yeah, and I think if you love that side, you should definitely start getting into databases. I took a SQL class like a long time ago now. I've done a lot with SQL, but I loved it so much. I was like, maybe I want to be a DBA. So it's interesting that I ended up in the data science because I've always loved data and working with data. So being a data geek is definitely something that is helpful in this field and with building it. So that's awesome. And I also like another point that you made is that you can't always get a good result with the model. And there's also like this good enough kind of idea. So how do you decide if a model is predicting good enough?
It honestly depends on the field and what's going on. In certain scenarios, good enough is, saying that the roller coaster is going to break before it breaks, because there's so many safety features built into it. Naturally, you're catching 25 to 50% of the breaks before they happen. And then the other maintenance that's regularly done, it goes in and does it. But like in other things, like in a nuclear power plant, you want to catch all the breaks before they happen, even though you have the A, B, and C plans in place. So it's really depending on who you're talking with and how they deal with a break in that space. And to drop some jargon, it's precision and recall and accuracy and all these different things that go on. And you have to make sure you are delivering what your customer wants. Customer being like the end user and what they expect to see out there. So there's a lot of working with people who are experts in their field to try to figure out and build a model that's intuitive to the way that they want it to behave. Because as a data scientist, if I come in and put a model in, it's not intuitive to the way that the field operates. And I've worked in everything from ag to fraud to nuclear power plants, roller coasters, and servers. So I've been all over the place, and it's been a lot of fun, and I've learned a lot of different things.
Yeah, and let's talk a little bit more now about that predictive maintenance, because you were talking about some of those models that you've built and kind of how you had to decide whether they were good enough and working with the customer, and kind of sometimes it's about helping them understand that something is good enough too, because I think a lot of times in programming we think it works or it doesn't, right? And in machine learning, it's always like, I feel like it's more gray, like it works good enough. So let's talk a little bit more about predictive maintenance and what it is and some of the different things that you've built with it.
So predictive maintenance has a silly name because it's predicting maintenance. You want to say something breaks before it breaks, so that way it can be fixed in the natural rhythm and flow of the environment that it's in. So for roller coasters, you want to fix them in the middle of the night when no one's riding on them. And for different machining plants, you want to fix it between different shifts when no one's actually operating or creating product. On servers, you fix it when a job isn't running and you have to purposely like block it off and be like, don't go on the server. And so it's very different for each field. It is basically the main story about maintenance and predictive maintenance and how it's defined. Usually all of these different fields have planned maintenance that already exists in it. And the idea is that we're going to save human hours by reducing the planned maintenance. So, every single day someone goes out and checks the brakes on something. Rather, we're going to put an edge device that actually checks the brakes for a human. And when we see that the brake isn't behaving in the perfect way, someone's going to go out and check it and do the maintenance then, rather than spending 15 minutes every single day to check every single brake. So it's definitely, the goal is to save human time and increase customer experience or production time, what have you, for each discipline.
And in the roller coaster, safety too, right? So it's not only, it's like there's a safety side of it. So we're actually making sure that we're making things better. I have a fear of roller coasters. And so during your talk, when you were talking about the roller coaster ones, I think my hands were getting a little clammy. And I was like, and this is why I don't go on them, because they break. But they don't, because there's people like you building models and maintenance people going out there making sure that they're safe for people to enjoy being terrified for some reason.
It's the adrenaline.
It must be. It must be. It's got to be something. And maybe I just have to get over that fear and then understand that it's safe and that, like, rushing towards the ground is fun for some reason, because you don't die at the bottom.
No, you don't. They're very, very safe. Let me stress that. And then the maintenance algorithms are very, very accurate. So it's very important to stress that, especially with nuclear power plants and with roller coasters. They have an A system and a B system and a C plan. And then on top of it, they have predictive maintenance. So the idea is that you will be safe.
That's good to know. So the predictive maintenance is on top of like multiple backup plans. So you were talking about sensor data and IoT Edge, and I've been playing with this Azure Percept I have over here, which is an IoT Edge device that has a camera, a mic, and a board. That makes it easy to build. So I want to hear more about some of this IoT sensor data and what are, like, do you know a little bit about the architecture, what kind of sensors they're using, or kind of like what's your experience with IoT Edge and AI?
So my experience with the IoT Edge and AI is different for each application. It depends on what you're monitoring, whether it's a vibration sensor or a video feed to make sure the temperatures on everything are within the appropriate bounds. So you do thermal scans regularly with cameras. You can do LiDAR to see like the depth of where things are and to make sure things haven't moved. There's analog sensors saying like, it's at 3 or it's at 5. And there are other sensors. A lot of what I worked with was binary sensors. So a lot of ones and zeros at the millisecond level, which, it just like your eyes glaze over when you just look at a screen of ones and zeros. It's normal, but turning that into something that's actually meaningful is really fun and cool. You wouldn't think binary data is like the cool data, but I'm like, binary and vibration sensors, like those are my jam. Okay.
That's awesome. I imagine like cleaning the data and normalizing it is a bit easier as well, because you're already dealing with ones and zeros and that. So is it more, what's kind of the hard part obviously there's lots of hard parts, but what is like the harder part? Because for me, I'm dealing with like a lot of sometimes like natural language processing or images, and there's a lot of process to get it to the point where it's ready to be put in. So what kind of cleaning do you do on the binary data? Other than like invalid values. I know we talked about that a little bit already.
Yeah, no, you're cool. So what happens is every single millisecond they come in and they say it's 0, 0, 0, even if it doesn't change. And so dropping that down to a timestamp and just like a 1 or a 0 when it actually changes is one way to look at quite a significantly smaller amount of data, and then actually aggregating those values out to the hourly level or to like 10 or 15 minute levels in some sort of metric, which is kind of the secret sauce to everything that goes on, is the way to go, because looking at the binary data at that level, it's not too meaningful. You can't just shove that into a model, unfortunately.
Yeah. So then what kind of algorithms are you using on that data, and kind of what's your process of picking and going through your hyperparameters? And I know we're getting into a little bit of a jargon here, so maybe we should explain what some of those things are as well as we talk about how we would do that.
So at the algorithm level, if you will, I'm assuming you mean from like, how do you do, we call it the change table. So the ones that actually transition into an actual aggregate, you look at like how many times it actually transitions, or other sort of metrics at that point that start being correlated to what we call the ground truth, or where the maintenance actually happens. And we have to have some historic data. We can't just go in, put the sensors on and be like, okay, Sarah, let's put in some machine learning. I actually need to see some maintenance data alongside the sensor data so I can see if there are spikes or drops in certain metrics, and hook that up. And we call that the ground truth. But a lot of what it operates in is kind of an unsupervised space. Unsupervised being like, hey, I have a bunch of, like in a y equals mx plus b type setting, you just have a bunch of X's and you don't have any Y's, and you kind of have to check your answers against the correct answers in the maintenance log. And there is NLP in this space. Doing fuzzy string logic, because, you know, someone goes out and says, hi, I looked at the server and it was behaving weird. And half the time I have to be like, hey, who was the guy that did maintenance last night? I don't know what the server is referring to. Can we like start putting in like the server numbers? And then you have to use fuzzy string logic, like what server is this matching closely to in my naming lexicon? And so there's a lot of different steps that you go through. And so it isn't just very straightforward, like throwing machine learning on. Most real world problems with machine learning and data science are horribly complex, and you're trying to shake out the noise and find the signal in it. I like to think of myself like a data detective, if you will.
I love that title. We should change that to data detective, like, because you're finding, you're like, how do I take all of this information and make something useful? How do I clean out the noise? It's interesting to think about the notes that you have to go through and kind of make sense of those as well, to correlate that to then your data to then help with those predictions. And I think, so when we do a lot of the tutorials that you see, I think are supervised learning. You mentioned unsupervised learning. Can you tell me a little bit about what each of those are?
So supervised learning is a fun space, as well as unsupervised, in which you have I keep going back to like y equals mx plus b, but you have the answer key, so you can train the model and tell it to go out and behave in a certain way. In an unsupervised space, you don't have the answer key, and so it's like going out and taking a test and turning it into the teacher and asking them to grade it for you to see how it does. So you can't do a one-to-one match. Is what happens, because we know maintenance happens here, and we want the alarm, depends on the customer, to happen within a certain amount of time before the maintenance event actually happened when you're training it. And so you have the algorithm go out and say, here's an alarm, and then you go check the answer key. Oh, someone performed maintenance, or it comes back and says, here's an alarm, and you're like, there is no maintenance event that is associated with this. You're a bad algorithm. Go back and think about what you did.
You need more training. Go back to the GPU server and learn something new. That's our jobs, data scientists. Go, you're in a timeout. No, I'm just kidding. That's where the moms are, like, we're both moms. So it's like, that's where the mom comes in, and there's like the machine learnings are like our little babies that we're training. That's what I think about when I'm building things. Cool. So that really gave us a better idea of some of the ways that you go about building, and some of the like difficulties in it as well, dealing with these large data sets. And you know, a lot of those you can't fit into memory either. So you're dealing with probably like a subset then of that data, or are you doing parallelism, or how are you handling these large data sets?
So it kind of depends on the problem that I'm working with. I've used multi-threading. I've definitely used Spark quite a bit. And then you can do different sampling schemas, because usually you can't graph things in Spark. And so you have to try to sample things correctly, which in and of itself is a whole host of problems. How do you sample 6 billion records and do it accurately to represent the whole data, because pandas can only hold so much, and it's not even a fraction of what's there.
Yeah, and I want to invite people that are watching to ask questions in the chat too. I'm keeping an eye on it. So I'm getting all my questions answered, and now I want to like do a predictive maintenance problem. Is there like a Hello World or like a resource or something if they're interested in like learning more about building predictive maintenance models that you would recommend?
So my favorite thing that I've worked through is Manning's Deep Learning with Python book. It was the gentleman who actually created the Keras package for Python. And I found it insanely helpful and focusing a lot on time series techniques. There actually isn't a predictive maintenance book that I've found. I've worked through quite a few books, but there's a lot of self-teaching, and definitely had it on my brain to write a book for a while now.
Oh my gosh, that would be amazing. I've done a little bit of time series, and when you were talking about the timestamps and the predictive maintenance and all the data, I was kind of thinking back to some of the things that I've used in different time series things. So that would be another thing to look up then when you're thinking about predictive maintenance, would be looking up how to do time series problems. And I think half of learning and understanding different things is knowing the right words to Google in Bing.
Mm-hmm.
And so
I mean, if I didn't have Stack Overflow, and most of the programmers I know didn't have Stack Overflow, I think we would be lost, because we use it all the time to, like, how do I do this programming thing, and go out and kidnap some code.
And if you switch languages a lot, like I switch around and do a lot of different languages, sometimes like the syntax, you're like, you write the wrong syntax in the wrong language. And so let's talk a little bit about languages. What is your go-to language, and what's the main ones that you use in your processes?
So my personal favorite, I might get a boo from the audience, is R. I love it.
I'm just kidding.
But I do... Don't shoot. I do use Python regularly. SQL is an absolute must. You cannot function in this environment without knowing SQL. And I know SAS, but some people might not be old enough to know what SAS is. So statistical analysis software, but that's from my stats days.
Cool. Yeah, I do more Python. I think there's more community around Python. It tends to be more popular. And then using like libraries like TensorFlow and PyTorch. So I could keep talking about this with you for hours, but we unfortunately don't have hours. So I want to thank you so much for being here. And I think, yeah, I can't ask any more questions. So thank you so much.
Thank you so much for having me. I really appreciate it.
Oh, well, thank you both, Cassie and Sarah. And I love that term, data detective, first of all. And then, like, the fact knowing that predictive maintenance is keeping me safe on roller coasters makes me feel a little bit better. So thanks. Thank you both for that. And make sure to check out Sarah's podcast too, Sarah and Tech.